started. If you haven't picked up your textbook yet, today we are working in textbook number 2. Textbook number 2. That is the one over on the shelf next to my table, and you are going to open to page 475. Does this filter make my eyes look big? Make sure you have something to write with. None of this funny business.
Okay.
Yesterday, we talked about additive relationships. You came up with an equation, y equals x plus a. Today, we're shifting gears, and now we're going to talk about multiplicative relationships. Okay, now we're ready to begin for real. Okay, take a look at the equation. Yesterday, you came up with them, y equals x plus a. Today, we are going to be using an equation that looks more like y equals a times x.
Let's start on page 475. It says that Leanne is training for a marathon. She knows that each kilometer she runs is approximately or about equal to 0.62 miles or 62 hundredths of a mile. How many miles does she run if she runs 5 kilometers? So we begin first with filling out the table. And so it tells me that she can run about 0.62 or 62 hundredths of a mile for each kilometer. So if she were to run 1 kilometer, you guessed it, it would be the same as 0.62 or 62 hundredths of a mile. So we would need to use this same idea to help us determine how we would complete the rest of this table. And I hope that you're completing this along with me. And so let's keep going. I want to know how long it would take to complete 2 kilometers at the same rate. So as you know, we have to go over to the side and we have to use our numbers and our number sense to do a little bit of math. So I'm going to try to multiply it times 2 this time. And I know that 2 times 2 is 4 and 6 times 2 is 12. Now I have to count my decimal places 1, 2, and I can plug in my decimal and I have 1 and 24 hundredths of a mile. And we want to continue to go at this same rate. And if we were to multiply 62 hundredths times 3 and 62 hundredths times 4, we would get the remainder of this table. So if you will please pause the video now, and you can either send someone to the board to solve these, or you can have students take a minute to solve them on their own. When you start the video back up, then we will be able to fill these in. Okay. So after you solved by multiplying, you should have come up with 1.86 and 2.48. So now we're ready to move a little further. We need to graph the ordered pairs. It tells me that kilometers is first, so we know that would be our x, and that miles is second. So we need to graph those on this chart. Now, I want you to notice that these are written as decimals and these are written as whole numbers. That could be a little tricky for some of us, but we really have to use our number sense here. My first set is 1 and 0.62. So I go over to 1, and I know that 0.62 is a little bit more than half because we know in our benchmark fractions that 1/2 is equal to the same thing as 0.5, or 0.50 as some of you like to think of it as 50 cents. So I would go over to 1 and up to 0.62, a little more than a half there. The next one I need to graph at 2. I go over 2 is my x, and I'm going to go up the y-axis to 1.25 or 1.24. 1.25 would be about a quarter of the way up. So I know, and then I'm going to be a little less, right about a quarter of the way up. The next one I have is 3. I go over to 3, and I'm going to go up to 1.86, which is nearly 2. Oh, got a little close. And my last one's going to be 4 and 2.48. And so when I go over to 4 and I go to 2.48, close to a half. Okay, I have a nice little line here represented with my point. And if I were to map this out, I would see a nice little line. But let's take a look at this. I could even label each of these. And if I labeled them, I would get the same ordered pairs that you see up here. So we think of this X and Y just as an ordered pair. Be careful and do not let your brain shut down on you just because you see these decimals. Use your number sense. Think if they are close to a quarter. Are they close to half? Are they close to 3/4? That's the best way we can do it. All right. So now if we use the graph, we can predict the number of miles she runs if she runs 5 kilometers. So if we were to do that, we could look at 5 kilometers and where we would fall. I feel like we would be somewhere in here. So I could predict that she would be about 3 miles. And I could even check my math by taking my 0.62 and multiplying it by 5. And I could do my math here. I have 31. So 2 decimal points, I can see 3.10. And we said about 3 miles, so we were pretty close. Remember that we are making a prediction, so we're not going to be right on. The last part wants me to write an equation to represent how many miles, Y, she will run if she runs X kilometers. So yesterday you told me this is a multiplicative relationship and that we were going to represent a multiplicative relationship as Y equals A times X. And we know that A can represent any number. This is any rational number. And so when we set this up, we should come up with an equation that says Y equals 0.62 or 0.62 times X. And I put my little X in parentheses there just because that's a lot of numbers and I didn't want it to get jumbled up. But there are other ways I can write this. I can just do it with an X and it would represent the same thing. Remember that we do not write it this time as X times 0.62. We do away with the multiplication symbol and we put our number in front of the X. And when we do, we're going to come up with something like this. All right, guys, if you will turn the page to page 476. Okay, guys, so we are just using the examples to determine if this is a multiplicative relationship. Yesterday, we worked really hard on additive relationships. You did a great job in being able to determine what was additive and what was multiplicative. So I have to look at my input and my output. When I look at my input and my output, I can see I have 7 and 14, 8 and 16, and 9 and 18. And I wonder if you notice a relationship between the input and the output. So if you'll go ahead and pause for just a minute and take a few answers. Okay, so you guys should have said that we were multiplying by 2. And multiplying by 2 tells me that this is actually a multiplicative equation. And it says each output is twice the input. Since the equation that represents this table is Y equals 2X, the relationship is multiplicative. So this one is true. It is a true multiplicative relationship. Let's take a look at the next one. I'm starting with 3 and I'm ending with 7. Starting with 5 and ending with 9, and starting with 8 and ending with 12. I can see that there is no real relationship that involves multiplying here, but I did see that, hey, I'm adding 4 and adding 4 and adding 4. That makes me think this is a different kind of relationship. It's not multiplicative. Instead, it is additive. So you should have said additive. This is an additive relationship. Each output is 4 more than the input. Since the relationship cannot be written as Y equals AX, it's not a multiplicative relationship. In fact, you could probably already tell me that this time Y equals X plus 4. That's going to give me Y. All right, let's look at a graph this time. A graph means, hey, I have to break this down into my X and my Y. And when I break this down into my X and my Y, I'm going to get some ideas here of what's happening. I can see that my first one is 0, 0. My second one, I go over to 4 this time and up to 1. And I go over to 8 and up to 2. When I look at these, what I'm doing, I'm if I were going from y to x, I know that I would be multiplying times 4. But since I'm going from x to y, I'm going to be multiplying by something that is smaller than 1. Let me show you a good example of what I mean. Do you remember when we said if we have something like 3 and we multiply 3 times 1/2, since this number is less than 1, we know the answer will be less than our first whole number. So in this situation, I have 4 and I need to get over to 1. I'm going to have to multiply by something that is less than 1. And so in this situation, you were probably able to pick out that I had to multiply by a fraction. And if I take 4 and I multiply it by 1/4, remember that I multiply across the top, I multiply across the bottom, and that would give me 4/4, which is the same thing as 1. And that's what I have right over here in my chart. So if I were to do that again and multiply 8 times 1/4, just to check my work, I know this goes over 1. If I multiply across the top and multiply across the bottom, I have an improper fraction and I can divide it to get a whole number of 2. So I'm multiplying times 1/4. So if we jump back over to our book, we could say that each y value was found by multiplying by 1/4. Since the relationship can be written as y equals 1/4 times x, or 1/4 x, it's a multiplicative relationship. So be careful because we don't always multiply by whole numbers. I want you guys to take just a minute to work on A, and I want to see you write that as an expression, as an equation. And I want to know, yes, is this multiplicative, or no, this is not multiplicative. So if you'll go ahead and pause the video. All right, let's take a look at this one together. If you work this out, you should have noticed that there's a relationship. 2 times what would get me to 6? Oh, to -6. Well, I know that I'm going to have to multiply by a -3. 4, let's check that. 4 times -3 would give me -12, and 6 times -3 would give me -18. So it is, in fact, multiplicative. You should have said yes, and you should have said that it is multiplicative because each y is being multiplied by -3. So I know that this would be y equals -3x. I want you to think about what a negative graph might look like. We haven't touched those yet, but a negative graph might go the opposite way. All right, let's take a look at this one. If you'll pause the video and go ahead and solve. Okay, so what you should have said is that I need to separate my x and y so that I can find a relationship. So the first one is I don't go anywhere, I don't go over, so I stay at 0 and go up to 2. This time I go over to 1 and up to 3, over to 2 and up to 4, and so on. And when I look at this, I can't find a real relationship here that involves multiplying. So you should have recognized that we are actually adding 2. This is not a multiplicative relationship. This is an additive relationship. And I could represent it with y equals x plus 2. All right, so here's what I'd like for you guys to do. If you will please turn the page one more time to page 479. I would like for you to complete number 1 and number 2 on page 479. I want you to check out the input and the output. Be careful, this is not a whole number. We have a rational number here that involves a decimal. I'm going to be multiplying by something different. My first clue is that it ends with 0.5. Okay, and here I want you to check the input and the output. I want you to be sure that you explain your answer thoroughly and you give me the equation that is tied to this relationship. Today we will not continue with number 3, but I would like for you to tear this out and turn it in. Our sub can make a pile of them or we can get them into the turn-in bucket. I will be looking for these when I come back. Once you guys finish, If you will go ahead and I have left a sort for you. It's an additive and multiplicative sort. So I want you to pay close attention to what it's asking you to do. And in some cases, it may be saying that we're adding something or that we're getting something additional each time. And in some cases, you might have to look for words that says 2 times as many or 4 times as many. So if you will be very careful on those, I want you to cut out the headings, glue them at the top of the page, and then you will cut out each one of the little statements, and you're going to glue them under the correct spot and turn those in. If you happen to finish this before the end of the class period, then I want you to get it turned in. If you do not finish, it is definitely your homework, so let's make sure we get it taken care of. Remember what I said to you about being on task today, getting done what needs to get done, making sure that I know that you understand the lesson so that we can enjoy a little bit of that fun time closer to our Christmas break. If you will get this turned in, you are more than welcome to be on Education Galaxy. We will save Prodigy for our pirate block, so you will be on Education Galaxy. You guys have a great day. Thank you for working so hard. I can't wait to see you back tomorrow and hear about who did an excellent job.